In this video, we'll demonstrate the data layouts of AWS Storage Gateway and LucidLink Log Structured Distributed File System. Both of our technologies we're comparing today are leveraging S3 as the back end. I have my storage gateway connected as G drive, which is empty and associated to the bucket called A Storage Gateway, which is also empty in our Asia Pac Sydney region. For LucidLink, I have a mount point to a file space called layout.filespace, also in the Sydney region. So if we look at its resource, it is layout.filespace bucket in Sydney and also empty. The test file that I'm going to use is a text file, 1 megabyte file, which is actually repeated content from our comparing methodologies for accessing AWS S3 blog post. It's highly compressible text, and I've repeated this blog post multiple times to equate to 1 megabyte of raw text data. So if we take this data as a first test and copy the file to our AWS storage gateway, paste it to our SMB storage gateway. Of course, being the SMB storage gateway, we're using traditional network protocols over the internet to a public IP address, which is a storage gateway running in AWS EC2. So now that we have a 1 megabyte file, let's look at the data layout by doing a refresh on the bucket, and we will see a one-to-one relationship between the file and the object. If we perform that same copy onto the LucidLink Log Structured Distributed File System file space, we'll see our acknowledgement immediately. We'll see that we'll upload, and when we do a refresh, we'll see our data layout is significantly different. So we now have 6 9 kilobyte objects which can make up the text file. Noting the difference that in LucidLink we compress the layout in the object store and we divide it into a log structured file system of multiple objects that span the individual file. So going back and looking at the S3 bucket for the AWS storage gateway, we have a one-to-one relationship of put and get when it comes to the data layout. To highlight that further, let's edit the file off our gateway and open it up in Notepad. The file has to open as a get from the AWS storage gateway and subsequently the object off the S3 bucket. So once that opens, we have our file, and we can control all, we can copy, and I'm going to double it by pasting twice to double the file size, lines from 5,800 to 11,000, and then I'm going to save it, which is then going to perform a put. I'm going to close the file. We can see we're now 2 megabytes. If we look at the data layout by doing a refresh, we'll see we're now 2 megabytes of consumption. Now let's perform that same task on Lucid by opening the 1 megabyte file in Notepad. It is now immediately accessible because of our cache and prefetcher. We're going to Control A and Control C to copy. We're going to Control V to paste twice to 11,000 lines. We're going to save the file. We're going to close the file. We now see 2 megabytes. We are going to do a refresh within the S3 bucket, and we will see we have more objects, all of which are 9 kilobytes. Remember, it's highly compressible. Garbage collection is now going to come through in a few minutes' time and clean up the expired objects from the metadata, the older objects. But even still, while we have all the objects there and we haven't yet expired, let's do a capacity of all the objects by getting size of the bucket, and we can see we've got 130 kilobytes in total. Now that also includes the metadata files that have, or data objects that have expired that haven't yet been cleaned up by garbage collection. If we perform the same get size within our AWS S3 bucket, we see a full 2 megabytes of price penalty within your S3 consumption. So to highlight the differences further, I'm going to let garbage collection clean up these objects. At this point, I will fast forward and check back in a few minutes. Okay, now that we've provided enough time for our garbage collection to clean up the objects that no longer exist within the file space, we can see we've changed from 14 to 10. So now we can have a true reflection of the size of our occupying the S3 bucket. We've got 93 kilobytes. Now note also, you've observed the difference in performance. We've cached and compressed the data. The data is actually encrypted at the client side with LucidLink and sent in compressed format. So our 2 megabyte text file has been compressed to only occupy the amount of capacity it truly needs in a compressed state. The data layout is encrypted, so any of the contents of this file has been encrypted at the client and is not visible within the object store as a traditional file. Contrastly, the file within the storage gateway that resides on the S3 bucket is its full original size and not encrypted at the client side. Its full original size and not compressed, and also the user experience between opening the files being significantly different when comparing the two of Lucid file system and the storage gateway because of the protocols employed. So at this point, you see the file has to be retrieved from the object store and opened within the editor as the complete file. Which clearly takes a considerable amount of time and can be sped up with local on-premise caching, etc. However, ultimately, you are doing full puts and gets out of the object store. Thank you.